Hello, my name is Amadrio Easter Babra. Today I'm here to take you through about the general overview of electrical generators. A generator is an electrical machine that converts mechanical energy into electrical energy through the principle of electromagnetic induction. Mechanical energy is supplied by a prime mover such as diesel engine, petrol engine, water turbine, wind turbine, or a steam turbine. Electrical generators are widely used to supply power during outages and in locations where the national electricity grid is unavailable. Principle of operation. A generator operates based on Faraday's law of electromagnetic induction, which states that when a conductor moves through a magnetic field or when the magnetic field around a conductor changes, an electromotive force, that is to say EMF, is induced in the conductor. If the conductor is a part of a closed circuit, currents flows. Main parts of a generator. First, stator. The stationary part that contains the armature or field windings. Second, rotor. The rotating part that produces or cuts the magnetic field. Third, armature. The winding where electrical voltage is generated. Fourth, field windings. Produce the magnetic field required for generation. Fifth, slip rings. Used in AC generators to transfer current from the rotating part. 6. Commutators. Used in DC generators to convert the generated AC into DC. 7. Brushes. Carbon conducts that transfer electrical current between rotating and stationary parts. 8. Prime movers. Supplies the mechanical energy needed to rotate the generator shaft. 9. Bearings. Support the rotating shaft and reduce friction. 10. Frame or housing. Protects internal components and provides mechanical support. We have types of generators. AC generators, that is to say alternators, produce alternating current, uses slip rings, commonly used in homes and industries and power stations. Second, DC generators, produces direct current, uses a commutator, used in battery charging or electroplating and some DC power systems. Classification of DC generators. We have permanent magnet generator, separately excited generator, self-excited generator, shunt generator, series generator, compound generator. Working of a generator. The prime mover rotates the rotor. The rotor creates a rotating magnetic field. The magnetic field cuts across the stator windings. An EMF is induced in the windings. Electrical power is delivered to the internal load. Factors affecting generated voltage: speed of rotation, strength of the magnetic field, number of turns in the armature winding, length of the conductor within the magnetic field, magnetic flux. Applications of generators: emergency power supply, hospitals and health centers, schools and universities, construction sites, factories and industries, telecommunication equipment, mining operation, agricultural irrigation systems, hydroelectric and wind power generation. Advantages: provides power backup power during outages. Reliable source of electricity, can be installed in remote areas, supports industrial and commercial operation. Available in different sizes and capacities. Disadvantages: requires regular maintenance. Fuel-powered generators produces emission. Can be noisy during operation. Fuel costs can be high. Risk of electric shock if improperly handled. Common generator faults: failure to start, low or no output voltage, overheating, excessive vibration, worn brushes or slip rings, low insulation resistance, bearing failure, fuel system problems, overloading. Maintenance practices: check engine oil or coolant levels, inspect fuel supply and filters. Clean air filters regularly. Tighten loose electrical connections. Test battery connection. Inspect brushes and slip rings. Lubricate bearings as recommended. Test insulation resistance. Keep the generator clean and dry. Run the generator periodically to ensure readiness. Safety precautions. Switch off the generator before maintenance. Ensure proper earthing into bracket grounding. Do not overload the generator. Operate in a well-ventilated area. Keep away from flammable materials. Wear appropriate personal protective equipment. Never refuel while the generator is running. Use insulated tools when working on electrical parts. In summary, generator theory is based on the conversion of mechanical energy into electrical energy using electromagnetic induction. Understanding the construction, operation, types, maintenance, application, and safety practices of generators enables electrical students to install, operate, troubleshoot, and maintain generator kindly and effectively. This knowledge is essential for electrical installation, maintenance, power generation, and industrial engineering. Thank you.